All right, a bit of a heavier topic here today in terms of the math demands. Now, we're looking at our compound interest. We're exploring it a little bit further. We're seeing what happens when the calculations are done a greater number of times or with a greater frequency. Our prerequisite skills are the compound interest. You need to make sure you're comfortable with these two equations as we went through in our previous lessons. If you're not comfortable with it, you're not ready for this video. This lesson is suitable for anyone exploring compound interest a little bit deeper. You might be in grade 9 exploring compound interest, grade 10, grade 11, grade 12, wherever you are, whenever you are, this is for you. Now, it's our goal here to take these two equations, which already have a fair bit of complexity to them, and make them a little bit more complicated. First, we need to go over some new words. Annually, if something happens annually, it happens one time per year. All right, if something happens semi-annually, semi meaning half, then it happens every half year. If it happens every half year, it happens 2 times per year. If it happens quarterly, it happens 4 times per year. That's every quarter of a year. That's 4 times in a year. If it happens monthly, 12 times per year. And if it happens weekly, that's 52 times per year. We'll add one more here to the end. I wish I'd included it already. I did not. If something happens daily, then it happens 365 times per year. Fantastic, nice and easy. These we would call frequencies. A frequency is how often something happens, how frequently something happens, right? So our frequency for annually would be once, or semi-annually, twice, etc. Now, we are going to change the formulas that we already had. We have already worked with A and P. We're going to dig a little bit deeper. We're going to use our frequencies to adjust our A and P values as we work forward. First of all, now we're going to write these in a little bit of a new way. All right, so our amount is equal to our principal times 1 plus, this time we're going to write an I here, and we're going to put it to an exponent n. That might seem a little bit wonky. That's okay. We can calculate our n value. Our n is the number of times that we're going to be performing a calculation. In the past, we have always assumed that our interest is calculated 1 time per year, but we could calculate more than that, because really, if money is being borrowed for half of a year, then people should pay for that as well. Or if money is being invested, you should be earning money over that half year. So we're going to break it down a little bit further. Our n value is the number of times something is calculated. If that's the case, then our n value really is going to come from our frequency times the number of years. Right? So our frequency is how often we are performing a calculation within a year, and we're going to multiply that times our number of years, which in the past we've just called t. Right? So next we'll notice maybe this I value. This I value is new. We used to call that R, now we're calling it I. Our I value is going to be the interest rate per time we are performing our calculation. So that might mean per year, if we're talking annually. It might mean per half year, if we're talking semi-annually, per quarter, per month, per week, or per day. It might mean any of those. We can work with our I value is going to be our interest rate, which we've already called R. It's going to be our interest rate, and we're going to divide that by our frequency. So you can see here that frequency is showing up in both of these calculations. And in one of them, it's multiplying when we're calculating how many times we'll be performing our calculations. And the other one, it's dividing when we're calculating what is our interest rate per period. Now, if we're working with these, we're going to also need to adjust our second equation. We'll work with our P, which is principal, is equal to the amount divided by 1 plus I, where we're making the same changes as before, to the power of n. And I'm hoping you can appreciate the differences here are minimal. We're just using some slightly different letters in the places, and we're going to be performing some extra steps to find these n values and I values. So let's put just these new 2 equations to the test for n and I. We're going to look at an investment at 4%. That /A means per annum, per year. Compounded semi-annually for 5 years. And we're looking to calculate an n value and an I value. Well, our n value is just going to come from, as we said, our frequency times our time. Our frequency, if it's compounded semi-annually, our frequency, I could just call that f, is 2. If we're investing this for 5 years, our t value is 5. And if we get 4% per annum, that is, our r value is 0.04. Okay, in which case our n value, let's come all the way from here. Our n value comes from multiplying our frequency, that's 2, times our time, that's 5. Okay, so 2 times 5, I throw that into my calculator. Our n value is 10, nice work us. Our I value, working from above, is going to come from our R value, in this case that's 0.04, divided by our frequency, that's 2. I throw that into my calculator, 0.02 is what I'm working with right here. Nice work. There's our n value, there's our R value. I encourage you, pause the video, try out B. I'm not going to show you how to do it, but I'll give you the answers in a moment. Good, we have our new n values, we have our new R value. Nice work, we performed our calculation. Let's go forward. We're going to find the n value, we're going to find the I value, and then we're going to apply these new values to our brand spanking new equations. Fantastic. I encourage you, question 2. We just practiced it twice. You should be able to pause the video here, find yourself your n value, find yourself your I value. Again, I'm not going to explain, I'll just show you the answer. Alright, I won't explain how we got those because you can see the algebra, but I will explain the meaning. The n value, that is the number of times we'll perform a calculation. So this means that 4 times per year, for 10 years, we're performing a calculation to see how much money is being borrowed. Nice and straightforward. If that's the case, that's the number of calculations. We're expecting that to show up in the exponent of our formula. Now, the I value is the amount of interest, or the percentage interest that shows up, the interest rate that shows up every quarter. All right, in this case, it's a quarter because it's compounded quarterly. So, if we're throwing these into our equations, we will need to do a little bit more work. We'll need to identify, okay, are we working with this $1,500? Is this an A value? Is it a P value? Well, a P value is your principal, that's your starting amount. If this is the amount that's invested into an account, that's our starting amount. So our P value is 1,500. That means that what we're looking for is our A value. We can throw that right into the equation that we've already been working with. Updated though, this time to include N and I. So A equals P, so our amount equals our principal value times 1 plus I this time, all to the power of N. Nice and straightforward. We'll plug in the numbers that we know. Well, we know our principal amount is $1,500. We know our 1 plus I is 0.02, all to the exponent 40. Now you might say, hang on, 40 seems like a huge exponent. It is. That's okay. That's being balanced out a little bit by this small interest rate. We'll see how it works together. We know what to expect. We're expecting a little bit more money. Now, $1,500, we're following our BEDMAS. You folks should be masters of this because of our prerequisite skills, so I'm not going to write out my BEDMAS this time. We're just going to work down. That is 1.02, all to the power of 40. That is, I'm working with 1,500 times 1.02 to the power of 40. I can throw that into my calculator. I know which button is my exponent button. You know which button is the exponent button because you've been practicing this on your calculator as well. 2.21 if I round. And then I throw that into my calculator once more. I'm multiplying by 1,500, telling me that we would end up with $3,312.06. That is our final amount if we invest $1,500 into an account for 10 years, compounded quarterly. Now, I encourage you, try out this next one on your own. Pause the video, get all of the values, figure out what you're working with, and then unpause the video just to see the setup. Then we'll practice going through and performing our calculations again. Go for it. Alrighty, so we're working here. Our n value is 10. That means we'll be performing the calculation 10 times. That will be our exponent. Our I value, our interest rate per half year in this case, is 0.025. What we're looking for, ready? Lexi would like to have $3,000. That means it's an A value, not a P value. That means it's an amount, not a principal amount. That means it's a final amount right there. So if that's the case, we're ready to use our equation looking for our principal value. Our P is going to be equal to A divided by 1 plus I to the power of N. Now we're plugging in the values that we know. Actually, you know what? Now I ask you, pause the video once more, try and perform your calculations. This should be nice and straightforward. You should just be using your prerequisite skills and see how you did. Good, okay. Does this answer make sense? We found that we are expecting to need to invest $2,343.75 today with these details in order to have $3,000 in 5 years. Does this answer make sense? Yes, it's less than $3,000. We're expecting our money to go up if we're investing it. Is it worth it? Well, that depends. If you have $2,343.75 available to you that you do not need to spend in the next 5 years so that it can grow in value, absolutely it's worth it. If you don't have that available to you, it's not worth it. But either way, I'm hoping that you feel a little bit more comfortable using our different frequencies to perform these calculations as we work through. Nice work.